So this lesson is going to concentrate on why CAD is bad and GIS is not ideal for planning as far as anything beyond databases. So let's talk about avoiding bad information. You're a planner, you designed a site, and you got the density right and everything else, but you ignored the grading and earthwork. Well, grading and earthwork can absolutely destroy the economics of a development, whether the developer goes ahead and purchases the site and then develops it and passes on the cost to the homes, or simply goes bankrupt. So it's a chicken and egg problem. The developer, this example, has a major builder. They went through the preliminary plat process, spent about $250,000 on fees, and during the preliminary plat stage, they discovered there was $2 million in earthwork for 100 homes, and they killed the project. And this is common. This isn't unusual. This is common. And this is why LandMentor combines design, engineering, planning, so that you could run these numbers at least on a preliminary basis, and then within the instructions we teach how to do proposed contours to try and balance the earthwork, and there's an art to that. So it's a system and egg approach. For example, when this particular site I'm talking about, we had to do a preliminary proposed contour, which you see here, on a very hilly site, and you have to be cognizant that you want to save the trees. There's a wooded site, and you can't move in the wooded areas ground up and down, because if you move ground up and down more than 6 inches, you are going to kill the trees. So you could think you're saving the trees, and then all of a sudden the earthwork is such that after you planned it from a bird's eye view, there are no trees on the site. So this is what LandMentor allows you to do if you dedicate yourself to learn it. So anyhow, this is a site where we wanted to create walkability. And you won't have walkability if you go up and down steep grades. So not only in the planning process are we trying to balance the earthwork so we could plummet the cost, so you're just moving the dirt from one part of the site to the other, and you're not taking dirt in and out, but then you're also looking at street grades, grades around the house, and then where your walking paths are, and you can't have steep slopes, because once you have steep slopes and you put a walk or a trail there, nobody's going to walk it. It is too difficult, and it won't be used for biking. So it's very important that you take a holistic approach, and that's what LandMentor allows you to do, because there isn't a surveying module or a civil engineering module. You don't have to be a civil engineer. It teaches you the basics of at least to get this far. And that's what makes LandMentor unique in the industry. And then we end up with a site, a beautiful site, that is not only more attractive, but it's far more affordable, and in this case we actually got the approvals and doubled the density. So it's very important that you understand the power this tool has beyond just everything else you've just learned. And that's what makes it unique. So we're going to talk about coordinate geometry mistakes and why CAD is bad. In CAD, it draws lines and arcs. And what it does, it draws from one XY coordinate to another XY coordinate. The line connected to the line you just drew goes from XY coordinate to XY coordinates. In other words, when you have two joining lines at the same point, you have two coordinates in memory. When you have 50 lines joining at the same point, you have 50 coordinates in memory. Some of them may have elevation, some of them may not. But what they don't have is a description. And when a surveyor is out in the field, he's collecting data, but he's collecting not just locations, he's collecting what that data is. Is it a building corner? Is it a curb? Is it a tree? And there's no way to know that in CAD because there's no facility for description. So what happens is, and data collectors use point numbers, so what happens is there's a block of data that contains the information for the coordinate geometry, and the drawing is completely separate. It is completely separate. And the thing in CAD, it has a mechanism called a hook. And a hook is connected to the block of information. So if this thing sounds kind of complex, it gets far worse than that. Because what happens is you're doing coordinate geometry on the blocks, and then hopefully the blocks, as you're creating things, is then creating a drawing and creating the hooks and creating the connections, but not everything's connected. Because not everything in CAD is coordinate geometry. And so things like dimensions, interactive dimensions, there's no interactive dimensions in CAD. They're all labels. Now there might be a mechanism say, well, this arc automatically calculates 80.78 along it, but what happens if you put corner circles and the line no longer goes through the arc? So what happens is the length of that would change, and the danger is, would the label change if it's interactive? Or if you're using those lines, they don't even connect anymore. So there's a huge danger in that because your coordinate geometry is hooked, but the lines are a different length than what you're hooked to. So the other thing about area in CAD is it has no mechanism because those are not joined fused corners. They're hooked together, so you have to tell it this point goes to this point, it goes to this point, it goes to this point. And what happens is maybe there's an automatic lot generation program that does that internally to CAD, but what about driveways, sidewalks, very complex things, parking lots? Well, that's not automatic. So you have to physically go to every little point, hopefully snapping to the right point to create a polyline to create the area to fill in. And to typically fill in with a pattern or cross-hatching. So that's why CAD is not GIS. GIS is a spatial program, and we'll get into that in a second. But that is why CAD is bad for the land development industry. With LandMentor, the only thing that exists, the only thing is the coordinate geometry. Every screen refresh is a raw calculation. Every plot is a raw calculation. Every area is a raw calculation. It is not a drafting system. It is a coordinate geometry system that drafts. Now let's talk about GIS, Geographic Information Systems. It is a core database tied to a map. GIS's maps are often done or mostly done by the lowest bidder with really vague old information to work from. It's the database that's primary. The map is secondary if it's accurate at all. So this small area in Pontiac, Michigan, it takes 160,000 points to draw. There isn't a single accurate line in that database. So when mapping first came out, the GIS, it was 1970s. You had to generate a map quickly on a computer screen, and there was no quick computers. So he had to generate this huge city. So he couldn't have the time to draw an arc or a curve because curves took too long to draw. So the solution was to eliminate all curves, and you end up with tiny little lines. Well, that was in a rectangular world, but we're not in a rectangular world. It made sense 40 years ago, but not today. But GIS systems still hold on to that same premise. So when we overlaid the GIS map you just saw, which is in Oakland County, Michigan, one of the wealthiest counties in the United States, over the actual more accurate aerial photo, things didn't line up. Not by a foot or two. By the way, aerial map accuracy is only guaranteed to 5 foot horizontally. This is off by 40 feet. 40 feet. And then there's other areas on this map that are off as well. So here's the problem. Developers assume that city data is reliable. And they might look at the land and go, oh no, I don't want this piece of land because look at all the wetlands. Well, maybe there aren't any. Or, I'll buy this piece of land. Look, there's nothing encumbering it. Well, maybe there is. And so really bad decisions are made on that information. Here's the bigger problem. Architects and planners assume this is accurate data for the most part. Architects and planners say, I can build off this data. I could do things off this garbage. It's garbage. And most engineers and surveyors know that if they use this data, they're going to end up in court with a lawsuit. So they don't use the data. So this also creates this barrier between the design planner and architect and then the engineer and surveyor. And this is really bad. And it's cost a lot of money. It's cost more money than the value of the map overall. Now, if that isn't bad enough, this is a LiDAR map. Now, do you see those jiggly little lines? That doesn't happen in real life. That's overload of computer. This is what a city would be given today as something acceptable. So when you take a look at this, can you see where the road is? Well, there's the center of the street, and those are the top edges of the pavement, which does not show the top of curb and bottom of curb because LiDAR can't get that kind of information. LiDAR is a laser that comes out of a helicopter or airplane or drone today that sprays millions of points. The computer doesn't know how to handle the millions of points, so they create this trash that cities pay extra for. Because why? Because the aerial mapping company doesn't have to hire a human being anymore to create the contour map. So they're saving money, but the problem is they're costing everybody else money. This is a contour map from 100 years ago. That's what a contour map should look like, not that trash. That's a 100-year-old hand-drawn map. In fact, LiDAR's only been around for about a decade, so anything you see a decade before will look like this. But now we get this garbage. So what you saw before in the LiDAR was about the little area to the right, and that's almost 100,000 points. And that's actually not bad for a site this big. In LiDAR, it's usually much worse. Guess what? You can't use this data. It's garbage. So someone has to manually edit. Takes about a day's work, and even then, the data's vague. It's not even exact. So we've gone so far backwards because we don't want to make an effort, and this is the problem. You are in an industry that doesn't want to make an effort anymore. And what you need to do is take and learn LandMentor, which is going to take you an effort, but you're going to have a career that you are going to make a difference and reverse this terrible trend that's happening in the industry. And we'll have good data to work with, and you'll be able to make decisions saying, wait a second, this is garbage. Here, give me good work and then you get paid. That's the way the world works. So we do have ways in LandMentor to automatically filter this, to reduce it from a day's worth of work to just a few minutes, but it's still garbage data. So that was 100,000 points. This is a land area that's a little bit smaller, and this is what a contour map should look like. You can see the center of the street, it's nice and crisp, and you see the Z-shaped lines or the W-shaped lines. That means it hit the bottom of the curb and the contour is going up the top of the curb, and then you see this other straight line underneath. There's a little drainage ditch there. This is what contour maps look like. Now, how many points do you think it took to draw all these contour lines? It took almost 100,000 on a site that's about 4 times the size. So you would think maybe 25,000 points? Well, it took 640 points. 640. So if we took the contours and we designed and we showed them not a 2-foot interval but a 1/2 foot interval, how many points in LandMentor do you think that took? Well, it took the same 640 points. That's what contour maps should look like. That's a contour map. You could even see above the head of the woman surveyor, see that sharp line? That's going up and down a curb in a parking lot. You can start seeing the edge of the parking lot. Now, that's impossible to do with LiDAR data. You cannot get that kind of data, which means you can't run precision numbers. So what good is it? It shows you generally the surface goes down here, up there, if you look at the numbers. In LandMentor, red is low, green is high. Can you tell where the low area is? So the same 640 points defines the physical surfaces, not just the contours, because the contour map is stored in a DTM, a digital train model. Contour lines are generated on the fly. Remember, LandMentor doesn't have anything but coordinate geometry. And every screen refresh, every contour map, every physical display of physical items is a raw calculation. And then the same 640 points were used to create the drawing. The same points. In CAD and GIS, this would start escalating and getting worse and worse as far as data structures. But if you combine everything, now you can visualize. And that's what business you're in. You're in a business to create things that are existing for a purpose or that are proposed. That's the business you're in. And when you look in CAD or GIS, it is a terrible mechanism to take and communicate with. And it's the same data that we could hit a single button and it knows if it's impervious or not. It knows things. So you hit a button and you can chart it and get this information, and that's value. This is what business you're in. And then another button, you give height to something and you get a digital massing of the site. And then if you drop some SketchUp models on it, well, now you can get an idea of scale. These are the existing trees, and I put some cars and some people on there so you can see scale. And that takes about a whole 2 minutes. And then because it's video gaming, you can use your Xbox 360 controller or your keyboard and just move about the site. So you can see the person and the building, and you can see how tall that building is. So cars and people gives you scale. Now on the GIS map, to draw those 9 lots in 2 dimensions in GIS, ESRI took 670 points to draw those lots because it can't draw a curve. To draw a curve, it needs a whole ton of points along the curves. To draw the curves, and those curves are not accurate to begin with, and 670 points. What you're looking at, all of this is 640 points. So you could start seeing a really big problem we've got in the industry. And so the LandMentor is there to reverse all of this problem. So we wanted to take this lesson to demonstrate why you need to learn this system to further your career, because what's out there is not going to do it. So the concluding thoughts for Lesson 11, both CAD and GIS compromises your career. They compromises your career, because you're going to need to use CAD or GIS otherwise. Cities need to retool. GIS has done nothing to expedite change. Just think of it. Look at it. You could Google Earth maps and you could go back in time. If some cities can go back into the 1960s. Take a look at the pattern in the 1960s and then take a look at the pattern today. And see if there's any change. And if there's change, it's probably changed for the worse, not for the better. And GIS has done nothing to expedite change. So why pay for and accept terrible work? And that's what's happening today. Unfiltered LiDAR. We need people to take and intervene and create good contour maps. And CAD and GIS companies have profited billions and billions of dollars. And yet nothing has changed. And nothing will change unless you change it. The software is a tool. It's a hammer. You got to have the knowledge that maybe you shouldn't be hammering a screw into the wall. It takes a screwdriver. So you got to think differently. We live in a world that's made up of surfaces, not lines and arcs. CAD and GIS fail to work well in that realm. You're in the surface business. In a new development, you are into new surfaces. If you're demonstrating something that is existing surfaces, and each one surface has a value, an economic and environmental impact. CAD and GIS doesn't think in those terms. So the problem is, why do you use a technology that allows you to think badly instead of releasing information that allows you to make better decisions? Automation can allow really terrible choices done quicker. LandMentor is here to reverse that, and we need you to learn it and get out there and make a difference. The next lessons will teach you on the demonstration and the communication using this technology.